G'day. We're continuing our journey in understanding how quadratic equations produce graphs of parabolas. And in the last video we talked about the y-intercept. That's the first of the four features that we look for. And in this video I'm going to give you an introduction into the second feature that we look at. You might recall that on a graph, on graph paper, when we graph a quadratic equation we will get a parabola. Now our last video showed us how to find this point, what we call the y-intercept, because it's where the parabola intercepts the y-axis. In this particular video, I'll change colours here, we're going to try, or at least introduce the idea of finding these intercepts, which we call x-intercepts, because it's where the parabola intercepts the x-axis. They're commonly also called zeros or roots. So you'll find them listed under any of those three names. Specifically, the roots and zeros are roots and zeros of the quadratic equation, whereas the x-intercept refers to the graph itself. But the same terminology is used. And we're going to spend a few videos learning how to find these, because there are a few tricks involved and a fair bit of understanding. And once those videos are complete, we're going to find the remaining features, which will be the axis of the parabola, because you'll remember that all parabolas are symmetric, and find the vertex as well. So that's what's coming. But let's look more closely here at the x-intercepts. Just as in our last video, to find where the y-intercept intersected the parabola, we needed the equation of the y-axis, which was x equals 0. In this case, we need the equation of the x-axis to understand where the parabola will meet it, or at least intersect it. And the equation for the x-axis is y equals 0. Now you might think it should be x equals 0, but in fact it's called the x-axis precisely because it's the x values that change. We have x equals 1, 2, 3, 4, 5 and so on. But the y value stays at 0 because we don't move up or down the y-axis. We stay right level with 0. So that is the equation for the y-axis, for the x-axis. Consequently, when we want to find these points, we solve the equation for the parabola, the quadratic equation, and the equation for the x-axis, y equals 0, simultaneously. Now that sounds like a big job, but it's much, much simpler than it sounds, at least to start with it is. And I recommend that you start by writing this sort of heading. Now this is the second feature we're looking at. And I like to write the heading either zeros, roots or x-intercepts. Because I'm looking at the quadratic equation, I often write roots, apart from the fact that it's one of the shortest ways of writing it. And next to it I explain how I'm going to find the roots. And that is, I'm going to substitute y equals 0. That's the heading I use. Now, after that we have a problem. And the problem is the quadratic equation you're given can come to you in a variety of forms. And we saw that in the last video as well. You might get it in what we call the factored form. And in this case it might look something like y equals x minus 3, x plus 1. You might have a constant out the front. You could get it in what's known as the general form. And this is when the entire quadratic is multiplied out. You might get something like 2x squared minus 5x plus 3. That would be a possibility. And you sometimes get it in the vertex form. And that's when you might have something like y minus 1 equals 3 lots of x plus 2 squared. Now you see these structures and these forms are quite different. If you multiply this out and rearrange them, they will look like this. They're all quite equivalent, but they certainly look different when they're handed to you or given to you in an exam. But in each case, to solve them, we substitute y equals 0. So for example, in this one, I would replace the y with a 0. In fact, what I prefer to do in this case is, because y equals all of that, I like to write equals 0 at the other end. So y equals 0. I could do the same here. Y equals this, equals 0. We'll just replace this y with a 0. This is a bit more tricky. I would in fact have to replace this y with a 0, and we'll talk about this a little later. And then we have to solve them. Now, this is an introductory video. It's going to take a while to explain all the different ways that we solve these. But let me say at this point that the factored form is the desired form. It is our best form for finding this second feature for the roots, or zeros. Now, I'm going to clear this. I'm going to demonstrate what I would write here, and then we'll have a close look at these other two, and then in subsequent videos I'm going to show you how to factorise these ones and make them look like this. But for the moment, let's see how this would behave when we're analysing it to look for this second feature. Now, I've already shown you the heading I would use. If I was given this quadratic equation, I would write it on the first line, and all I would do is, as I showed earlier, instead of replacing this y with a 0, I would write equals 0 over here. So y equals this, which equals 0. That achieves that purpose. The reason I do it is that mathematicians like to have the working part of our equation on the left and the 0 on the right. And it's just easier to do this. So now I'm going to solve the equation by working down under this equal sign. Now, I'm assuming that this is new to you, or at least you're struggling with it. I assume that if you understand quadratic equations, you're not watching this video. But if this is new to you, or you're struggling, I'm going to explain. Here we have three things multiplying to make 0. We have the number 5 multiplied by whatever this is. We call it a binomial, x minus 3. It's a binomial because it's got 2 bits. And it's multiplied by another binomial, x plus 1. So these three things multiply to make 0. Now, solving these kinds of equations relies on a very, very simple fact, and that is the simplest multiplication table you'll ever learn is your 0 times tables. Because 0 1s are 0, 0 2s are 0, 0 3s are 0, and so forth. You know that multiplying anything by 0 will give 0. The corollary, or the other side of that, is that if you multiply two numbers that are not 0, like 7 and 3, or minus 5 and plus 10 or something, you cannot get 0. One of these must be 0. Now 5 obviously isn't, but we have these two possibilities. Now, I'm going to work down the bottom to show you the full way of solving this, and then up here I'll show you the way that most mathematicians and most students are taught to do it, or like to do it. The full way to solve this is we could write 5 is not equal to 0, that's a bit obvious. But this could be 0. If that was worth 0, then 5 times 0 times that, whatever that's worth, would equal 0. And if that was 0, the whole thing would work. That times 0 would be 0. So we would say this. Therefore, either x minus 3 equals 0, so that's a possibility, or the x plus 1 could be worth 0. Now, if this is 0, I'm sure you know how to solve that. We remove the negative 3 by adding 3 to both sides of the equation. Now a lot of students I know will actually write the plus 3 in, but I'm going to be a little bit lazy here. Actually, perhaps I should write it. I'm trying not to assume too much. So minus 3 plus 3 is worth nothing, so we're left with just the x on this side. 0 plus 3 is 3. And on this side, we would subtract 1 from both sides. And we would get x equals 0 minus 1 is minus 1. They're the two solutions, and we would say, therefore, x could be either 3 or it could be negative 1. And mathematicians are quite happy listing all the possibilities with a comma between them. Now, if you can do this in your head, as most mathematicians and most experienced students do, all we would write is this last line. We would write x equals, and we would inspect, that's the term we use, we look at this, and we say what value of x would make that 0, and we say, well, 3 would. 3 minus 3 makes 0. The short way of looking at it is to do the exact opposite of what that is. So x would be 3, and what value of x would make that 0? Well, the opposite of plus 1. If x was minus 1 plus 1 would be 0. So rather than write all of this, which is actually the correct logic, mostly you'll see people just do this, and this is quite good. This is what we expect. And you can see why the factored form is so wonderful, and why we like it. I'm going to do it once or twice more very quickly, and then talk about the other two options. Let's have a quick look at these other examples. Now, I'm going to look at these two examples, and I hope you notice straight away that while this factor is a simple binomial, this one has a coefficient in front of the x. And that complicates things a little bit, not too much. And the same thing here. This one's a nice simple binomial, but this one has a constant, a coefficient in front of the x. So, how do we solve them? The same way. We set them equal to 0 because we're setting y equals 0. That's how we find the roots, or the zeros. Now, what value would make that 0? I hope you can see that it's going to be negative 4 or minus 4 because it's the opposite of this. That's easy. But what makes this 0? We have a problem, because if we use the opposite of minus 1, which is plus 1, and put it in place of x, we get 2 times 1 is 2, take away 1 is 1. We don't get 0. So it's not quite that simple. But let's think of the way we did it completely before. We would have said that was equal to 0 or that was equal to 0. Let's analyse that. If 2x minus 1 equals 0, what would we get? I think you see we could add 1 to both sides of the equation and get 2x equals 1. Divide both sides of the equation in half. Divide that by 2 and we just get 1x. Divide that by 2 and I would leave it as a half. You might prefer 0.5. This is the solution to this simple linear equation. I think you can see that the number on the top is the opposite of that. It has to be, because when we do the opposite, when we add 1 to both sides, it appears over here as the opposite. And the number on the bottom is whatever was in front of the x. So our solutions here would be negative 4, because we got that from a nice simple binomial. And here we would write the opposite of this, which is 1 over 2. That saves us going through this full explanation. In this particular quadratic, we would set it equal to 0. Again, that's what we're doing. We're setting y equals 0 to find the roots. And the roots will be these x values. Here, we would write the opposite of 4 over 3. And here we would write, if you like, the opposite of 2, the negative 2, which is plus 2, over 1. And you can see it's exactly the same as just writing the opposite of minus 2 is plus 2. I should have that out of the road now. Now, if you feel insecure about doing this, then of course you can write down here, therefore 3x plus 4 equals 0, or x minus 2 equals 0, and solve them the same way we did before. Add 2 to both sides, subtract 4 from both sides and divide both sides by 3. Now, of course, tidying this up requires a little bit of knowledge about fractions or decimals, and I'm not going to go into that at this point. But I think in a fairly full way I've shown how we can reason what we need to do to find the roots, that is, substitute y equals 0, the equation for the x-axis, and this is how we find the zeros or the roots from a factored form of an equation. Well, so far so good. We could really stop there, except that not all quadratic equations are given in this form. So what happens? I'm going to try and do this in about 60 seconds, so the video is not too long. But I'll wipe this and explain. Now, if you're given your quadratic equation in a different form, then we need to get it somehow into a factored form. Now, it turns out this one can be, and the topic for the next few videos is just how to achieve this, but this one would be, and this was quite accidental, I didn't prepare it this way, but this product does equal that. Trust me, we'll work that out in the next few videos. And to solve it, I'd go through this process, which we call factorising. Then I would set it equal to 0, for the same reason that y equals 0. And then I would simply write x equals plus 3 over 2 and plus 1. And they're my two roots. So this could be quite rapid, provided you know this skill. This one, we would have to set y equal to 0. So I would write 0 minus 1 equals 3 lots of, and then I would start expanding because I would have to rearrange the equation. X squared plus 4x plus 4, multiply it all out, 3x squared plus 12x plus 12, and I would add 1 to both sides, and that would make this 0, and I'll get 3x squared plus 12x plus 13, and if you like I'd put the 0 on this side because it's nicer to solve that way, and we would have to try to factorise that. Now this one cannot be factorised. There's a quick calculation you can make to check that, and we will discuss that in future videos. Why are some not able to be factorised? Simply because some parabolas don't reach the x-axis at all. So we never ever get any answers to our equation. Some of them will reach and just touch it, and we'll see what happens when that occurs, and some will cut in 2 positions, which is why we normally will get 2 roots. Because a parabola doesn't squiggle all over the place, we will never get more than 2. 2 is the maximum. And that's of course desirable. It makes our graphing much, much easier. So, there's our introduction. What have we learned? We've learned that parabolas can cut the axis in a variety of ways, but we particularly hope to get 2 roots. That the factored form is the best way of getting a result, and to get a result we need to set y equals 0 because that's the equation for our x-axis, and we do that, and our 2 zeros, the number x, the value of x that makes that 0 and the value of x that makes that 0, these 2 values are called the zeros for the quadratic. And if you wanted to graph the quadratic equation, obviously 2 minus 2, 0. One root would be at 3 on 2, which is 1.5. The other one would be at plus 1. So this parabola actually comes down and just passes through the x-axis and rises back up very quickly. Its 2 roots are very close together. So you can see that graphing the parabola can be quite easy if you know this skill well. So enough said. The next videos will teach you how to perform this operation, how to actually factorise quadratics efficiently. There's a lot of misinformation out there and some people find it very, very complicated. My videos will be a bit longer, but the intention is to help you understand very, very, very clearly what goes on and how to use the mechanics of it. If you've enjoyed this, please click on the like button. If you have a comment that's worthwhile, I would love to read it, so please leave that below the video. And of course, if you haven't already subscribed, then please subscribe so you can hear about the future videos as they arrive. and I thank you for watching.